So this section is what we call related rates. It relates to the Tootsie Roll lab that we did, even though really like the Tootsie Roll lab was designed for you guys to just kind of enjoy yourself and have fun. But I need a Tootsie Pop. But in the end, all of these, so every single time you have a derivative, it represents a rate of change, some sort of slope, okay? And so everything that you guys have done so far has been taking the derivative with respect to x being your independent variable. Now we're going to change our independent variable to being time, okay? So in this first example, I want to take the derivative with respect to time, okay? So I want to find dy dt when I'm given some information. So if I have y equals x squared plus 3, and I want to take the derivative with respect to time, so dy, it's not going to be dy dx, it'll be dy dt. So time is now my independent variable. And then I take the derivative of x squared, which is 2x, and then it's multiplied by a dx dt. So now what's in the denominator is kind of time, and now every variable in the world is now a dependent variable. So I want to find dy dt when I'm given some information. I'm given that x is equal to 1 and my dx dt is equal to 2. So dy dt is 4. With all these related rate questions, step 1 is to identify a equation. Step 2 is to take the derivative implicitly with respect to time. Step 3 is to then plug everything in. Do not plug in until after you've done step 1 and step 2. Okay? So don't plug in ahead of time. So example 2, a pebble is dropped into a calm pond causing ripples that form concentric circles. The radius r of the outer ripple is increasing at a constant rate of 1 foot per second. When the radius is 4 feet, what is the rate of the total area of the disturbed water? Okay. So I'm looking at circles. I want area of circles. So I need the formula for area, which is pi r squared. Take the derivative implicitly with respect to time. So capital A becomes a dA dt. My pi stays alone. My r squared becomes a 2r dr dt. And then I plug in what I know. Bless you. So dA dt is 2 pi. My radius is 4. My dr dt is 1 foot per second. So dA dt is 8 pi. Now, the question will be is what's the unit of measure, right? So if you don't know, you had a foot per second with your rate of change of the radius. You have 4 feet there, so then this is feet squared per second. So the units don't, like none of the units cancel out, they just multiply together. So when in doubt, leave your units there so that way you know what units of measure you're supposed to have in the end.
What is foot squared per second? Is that acceleration? I didn't take physics.
So rate of the change of the area.
Oh.
So we're not talking about anything. We're not talking about velocity or acceleration related to physics. We're only talking about area. So that is the rate of the change of the area. Other questions that you guys have? Example 3 is a spherical balloon. Air is being pumped into that balloon at a rate of 4.5 cubic feet per minute. Find the rate of the change of the radius when the radius is 2 feet. So I don't like this as being 4.5, so I will always change it to an improper fraction. So spherical balloon, so volume of a sphere is 4/3 pi r cubed. They're going to ask me if you need to memorize these. I will tell you that sometimes College Board is nice and it gives you these formulas. At other times they expect you to memorize them. Typically they look for basic shapes. So they're looking at spheres, cones, area of a circle, area of a square, area of a cube, cones, cylinders, spheres. Like every once in a while they would do something weird like a triangular prism. But all it is like the area of the triangle multiplied by the length of the prism. And then you'll need to know Pythagorean theorem. Area formula for a triangle. But you'll see all of these in the problem set. Okay, so I'm going to take my derivative with respect to time. So dv dt. My 4/3 pi stays out there. My derivative of r cubed is 3r squared dr dt. And then what you notice is that the 3's reduce. So dv dt is 4 pi r squared dr dt. And what you know is the volume's rate of change, which is 9/2 cubic feet per minute. And I know that my radius is 2 feet. Oops. And I'm trying to solve for dr dt. What you notice is I left my units of measure there, and the reason why I did that is because my biggest fear is like what's my rate of change? Like what's the units for my rate of change in the end? Right, and if I could physically see all of those units of measure cancel out, it's going to be a lot easier for me to know. Okay. So 9/2 feet cubed per minute. And then I have (16 pi feet squared times dr dt. So I want to solve for dr dt, which means I need to divide both sides by 16 pi. So I have 9 feet cubed. I'll write it better. (2 minutes) times 1/16 pi feet squared, and that's equal to dr dt. And now you'll be able to see like my feet squared, right, reduce with my feet cubed. So then I'm left with 9/32 pi, and this is feet per minute. Questions that you guys have? So as you look through your problem set, like cylinder, my biggest concern is you're not going to know how to do this one. Hold on, I'm getting there. Spherical balloon, we did a sphere already. Okay, so look at 7A, B, and C. This is a released question. I'm going to ask you for 7C as your end question for a reason, because I actually want you to get through all three parts. And you will actually have to do all three parts to do 7C. I'm doing it on purpose. I'm sorry. But I want to start you guys on this for a second. So you have a ladder 25 feet long, leaning against the wall of a house. The base of the ladder is being pulled away at a rate of 2 feet per second. How fast is the top of the ladder moving when the wall is 7 feet? And it should say from the wall. So, if I draw myself a triangle, right, here's my ladder. My ladder is 25 feet long. Base is 7 feet away, so I don't know what the height is. The base of the ladder is being pulled away at a rate of 2 feet per second. Okay, so I want to give you a bigger perspective for when you do this. I have a right triangle. I have side lengths of a right triangle, and I'm missing one side length. I also want to know what this rate of change is. So what formula relates sides of triangles together? Pythagorean theorem. So A, B, C. A squared plus B squared equals C squared. When I take my derivative implicitly, and I'm going to do it for you, I'll get you to a certain point and then you can finish solving. Okay, I know what A is. A is 7. I know what dA dt is. Now the question is, I'm going to ask you, is it a positive 2 feet per second or a negative 2 feet per second? Is the distance increasing or decreasing? It is increasing. So this is a positive 2 you're going to plug in. If the distance is decreasing, the rate of change is negative. I can figure out B by using the Pythagorean theorem. I know what C is. C is 25. dC dt represents the rate of change of the length of the ladder. Does the ladder change length? No, this is 0. And now you should be able to solve for dB dt. Okay. Questions about any of that? When you read the next one in the end is find the rate of the change of the area of the triangle. So I need area of a triangle. Area is equal to 1/2. In this case, I'm using an A and a B, base times height. So it's little a and little b. I probably should have used X and Y. I'm hoping you guys can tell the difference and that they're two different A's. Okay. When you do this derivative, this A times B is product rule. So it's B times the derivative of A, dA dt, plus A times the derivative of B, dB dt. And then you plug in everything that you know. You will have figured out dB dt from part A, and so you have to use it there. If your AP test has related rates, it will be like, I'm like 80% sure it will be something like this. Two ships going in different directions forming in a right triangle. Ladder sliding down the wall. Okay. The last one is rate of change of the angle between the ladder and the wall. So I'm going to label that angle theta. And I have to use tangent. You cannot use any other trig function. If you don't like it, go blame all the physicists. You have to use tangent only. So tangent of theta is equal to, in this case, opposite over adjacent, so A over B. You have to take the derivative now of both sides of the equation. I will do the hard part for you. Secant squared of theta, d theta dt. And then the right side is quotient rule. B times the derivative of A, dA dt. Minus A times the derivative of B, dB dt. Oops, I cannot write. All over B squared. Oops, that's not a B right there. It should be a 1. This was what gets everybody. Every single time I quiz or I test on this question, everybody dies here. And the reason why you die here is because you forget. That secant squared of theta. So what's B? Can anybody tell me what B is? Huh?
Yeah, root 576.
Good. B squared is equal to 576. So B is equal to the square root of 576, which is 24. It's a Pythagorean triple.
Why didn't I think that?
Well, so let's just say you don't know, right? Because you don't know. You have to break down the root. And then when you broke down the root, then you would have realized it was 24. Okay, the reason why I wanted you to know what it was is because I don't want you guys to ever miss this part. Everybody always gets stuck at the secant squared part. I have no idea why. I can find secant of that angle. Secant is hypotenuse over adjacent. So my secant squared is 25 over 24 squared. Is equal to this whole thing on the right side. And I will tell you guys, I would not get 625 over 576. Leave it as 25 squared over 24 squared, because what you're going to notice is that I have a b squared down here, and it's going to cancel out that 24 squared. So don't get super excited about trying to cancel stuff or simplifying stuff ahead of time. I typically don't square large numbers. I wait and see what happens afterwards. Okay, but you should be able to get dAd or d theta dt from here. And this unit of measure, so theta is always in radians from this point forward, and so it'll be radians per second is your unit of measure. And it's always radians, unless they say something different. Okay. Questions that you guys have. So finish 7, because I want to see 7C before you leave. Okay?